now I will welcome Marius Poke on the stage. He's from Informal Systems, and he will talk about precisely this topic. Welcome, Marius.
Yeah, thanks, Yuri. Hi everyone. My name is Marius Poke, and today I'm going to talk about interchain security. In a nutshell, interchain security will enable the Cosmos Hub to share its high security with the rest of the interchain ecosystem. Essentially, this means that IBC-enabled chains will be able to leverage the trusted and decentralized validator set of the hub and deploy their projects without actually worrying about bootstrapping their own validator set. So before I go into all this, I would like to say a few words about myself and the company that I'm working at. So I'm a research engineer at Informal, part of the protocol design team. The goal of the team is to design and specify protocols with an emphasis on correctness. Basically, this means that we make sure that the required properties, safety and liveness properties, are guaranteed. The focus of my work is to design and specify protocols that bring value to the hub. One of these protocols is interchain security. Informal Systems is a cooperatively owned organization with more than 50 members from all over the world. Our work revolves around three main things: applications, infrastructure, and the Cosmos Hub. First, we offer tools and services to improve development velocity, testing, and the confidence of blockchain applications. For example, we develop formal verification tools such as model-based testing and Apache model tester that enable us to provide security audits to the blockchain ecosystem. Second, we build and operate robust nodes and relaying software that power the interchain. We've seen yesterday Adi mentioning in his talk the Hermes relayer, which is developed and maintained at Informal Systems. Also, our partners from Cephalopod Equipment are operating nodes on multiple chains and relaying packets between these chains. Finally, we improve the value of the hub by enabling it to provide sustainable and scalable services to the rest of the interchain. Interchain security is one of these services, and we will see by the end of my talk that it brings value not only to the hub, but to the entire ecosystem. So, since interchain security is about providing security, it will be smart to start with seeing what's the security model in Cosmos. Cosmos chains are based on proof of stake, most exactly delegated proof of stake, which means that token holders are delegating their tokens to validators, which are then responsible for providing security, for making sure that the chain is secured. We can split this proof of stake into four main operations, right? So to participate in the consensus algorithm, validators need to bond their tokens. This is a well-known mechanism against the nothing at stake attack. These tokens are giving validators voting power. This voting power can be used to validate and vote for blocks. To encourage voting, validators get rewards that are then distributed to the delegators. Now, this voting power can also be used to misbehave, which means basically that the validators are not following the rules of the protocol. This can be double signing or light client attacks or things like this. As a deterrent for misbehavior, validators get their tokens, their bonded tokens, slashed. Finally, to enable the detection of this misbehavior, the validators and the delegators need to wait for a certain period of time, known as the unbonding period, before they can unbond their tokens. During this period, evidence of misbehavior can be submitted to the system. Interchain security basically can be seen as a multi-chain proof of stake. What it means is that we distribute the for operation from before across two chains. One is the provider chain, also, for example, the hub, the Cosmos hub. And the other one is the consumer chain. The two chains are connected through the IBC protocol. So here on one side, we see the Cosmos hub, and we'll focus on it for a while. Right? What's important to understand with interchain security is that it doesn't change the security model of the hub. We'll have exactly the same actions as before. Validators are bonding atoms. As a result, they get voting power. They use this voting power to produce blocks on the hub. Right? They get rewards as a result, which are distributed to the atom delegators. If they misbehave, their atoms get slashed. And to unbond these atoms, you need to wait for the unbonding period to elapse on the hub. Now, what we want to do with interchain security is to replicate the validator set from the hub on the consumer chain. For that, we use the same bonded atoms as before. Right? So validators have their bonded atoms on the hub, and as a result, now they get also validating voting power on the consumer chain. This grants them permission to participate in the consensus protocol on the consumer chain and vote for blocks on the consumer chain. As a reward, they get fees on the hub, which can be distributed then to atom delegators. If validators misbehave on the consumer chain, then their bonded atoms are getting slashed. Finally, to ensure that evidence can be submitted also to misbehavior on the consumer chain, to unbond atoms, now you have to wait not only for the unbonding period to elapse on the hub, but also on the consumer chain. Now that we've seen at a high level how interchain security works, we can move on to the why. And in a nutshell, interchain security provides sharding with shared security. Without interchain security, we can have either one or the other, but not both. For example, we can have sharding without shared security. This is the typical example of application-specific blockchains deployed in Cosmos and interconnected with IBC. It's basically the interchain. Right, so here on one side, we have the hub that we all know and we kind of love. So the hub is secured by 175 validators that are trusted and decentralized, and these validators have a total bond of more than $2 billion. And this is today in a bear market. Also, the hub is secured by Atom. The Atom has the highest market cap in the Cosmos network, or at least in the interchain. On top of that, the hub acts as an on-ramp and off-ramp to the rest of the ecosystem, which means that it gets value from the entire ecosystem. On the other side, we have an application-specific blockchain. Right? This is built on top of Cosmos SDK and also has its own native token. The advantage of such an approach is that the application running on this application-specific chain do not have to compete with applications running on the hub. They do not have to share the same block space. However, the downsides are that this chain now has to bootstrap its own validator set, which has to be sufficiently decentralized, has to be trusted. Even more, depending on the market cap of this native token, the security can be lower. Finally, to get an incentive alignment with the hub, what happens now in practice, a lot of these chains are airdropping tokens to Atom holders. And we've seen in the past that this is riddled with problems. Alternatively, we can have shared security, however, without sharding. So this is an example of actually deploying Cosmos on the hub, bear with me. And basically, this will allow having multiple smart contracts be directly on the hub. The advantage of such an approach is indeed all the smart contracts will share the same security as the hub. Right? They will not have to worry about validator sets or anything like this. However, such an approach has limited scalability. Since the smart contracts are sharing the same block space with other applications running on the hub, you cannot really scale such a solution. For the same reason, the gas fees are unpredictable, and potentially they can be high, as is the case with Ethereum. And finally, and quite relevant today, is Proposal 69, which we tried to put it and it didn't pass. And that's actually for some good reasons. There were security concerns, and the good part is that interchain security can solve all of these problems. Can actually provide sharding with shared security. So in the middle here we have the hub, again with high security provided by 175 validators that are trusted and decentralized, secured by the atom. Great. So the hub now is using the interchain security protocol to share its high security with the rest of the interchain ecosystem. Right? And basically is giving the shared security to consumer chains. We distinguish here about two types of consumer chains. On one side, we have the custom consumer chain. This is a chain with its own native token and built on top of Cosmos SDK. This means that developers can customize the entire chain logic. A good example of this is Quicksilver, and we'll hear later a talk from Joe about it, so yeah, quite excited. On the other side, we have the so-called contract consumer chain. This is a chain that has COSM-WASM or EFM enabled on it, and deploy on top of this only a smart contract we deploy. The idea is that now developers can customize only the contract chain. They don't have access to the chain logic, right? So only the contract logic. Also, to keep it simple, the gas fees will be paid in atoms. Good. So this can be seen, if we think about it, as a very lightweight chain, or as we like to call it, a supercharged smart contract. Regardless of the type of consumer chain, what's very important to understand is that all the consumer chains will have exactly the same security as the hub. The two flavors of consumer chains that we described before have different implications when it comes to developers and operators. In both cases, all consumer chains have to pass a governance proposal on the hub to be accepted as consumer chain. Why is that? Once the chain is accepted as a consumer chain, validators need to start running a full validator node of that, so a validator node of the chain, unless they will risk getting slashed for downtime. The difference between them is the following. So the contract chain on one side, as we said before, developers can only customize the contract logic, right? Also, the fees, the gas fees, are in Atom. This makes this chain very likely to be accepted. It doesn't really have any major impacts on the hub. Right? So this will be the perfect scenario for projects that do not want to care about a native token or about security or about any of this, just deploy on a secure chain and have the benefits of such a technology. On the other side, we have the custom consumer chain, right? As we said before, this is built on top of Cosmos SDK, which means that developers have access, can customize the entire chain logic, and the native token, then the gas fees are in the native token. Right? And these gas fees, some of them at least, will go to the hub. As a result, to get these chains to be consumer chains, most likely the validators will have to be more careful when accepting them, right? When passing the proposal. This can be seen as a clear incentive alignment, as a mechanism for having clear incentive alignments with the hub. We can think of the governance proposal as a method for the Atom delegators to actually audit this chain. This is quite cool. The two types of chains also have different implications when it comes to tokenomics. two types of consumer chain. So in the case of the custom consumer chain, as I said before, the gas fees are paid in native tokens. These native tokens can be furtherly inflated, as is the case with many Cosmos chains. A big chunk of this can be kept on-chain. A big chunk of the rewards from the gas fees and from the inflated token can be kept on-chain and used for things like governance, liquidity pools, and other protocols. However, a small chunk will be sent to the validators and delegators of the hub. This can be seen as a continuous airdrop. Billy kind of mentioned this in his talk before, and I think it's a very powerful feature of interchain security. This will enable basically the Atom delegators to participate in all these projects and not have to bother with weird mechanism for airdrops or anything like this. Next, the contra consumer chain has the tokenomics are a bit different, right? Because the gas fees now are paid in atoms. As I said before, these are chains that are running a single smart contract, so they do not have to share the block space with other applications or other smart contracts. This makes the gas fees predictable. This is quite a cool feature, right? And a part of these fees will be sent to the hub validators and delegators as rewards for providing security. However, big chunk can be kept on the chain, right, and distributed to the community that actually helped develop this protocol, to be, for example, to a community DAO. So to sum up, interchain security is almost here, and it will be awesome. Why I'm saying that? It basically will enable multiple stakeholders in the ecosystem to benefit from it. First, it will enable the Cosmos ecosystem to grow by allowing projects to easily deploy on secure chains without having to worry about bootstrapping a validator set that is sufficiently decentralized, with sufficiently market cap, and all these things, right? Second, it will enable the Atom delegators to receive rewards in different tokens and to participate in all these projects. Will basically make the interchain more connected, which is quite nice. And finally, it will enable the Cosmos Hub to experiment with new features. We've seen recently how, with Proposal 69 now, we wanted to put CosmWasm on the hub, but it failed. And again, there were some security concerns for that, right? Now what we could do is to just deploy CosmWasm on a consumer chain, and in case that consumer chain fails, the hub will not suffer absolutely at all, right? So this is quite a nice feature. Finally, I would like to say that we are hiring core developers, and in case you want to talk to us about interchain security or in general, you can contact us at hello@informal.systems. Thank you. Now, any questions?
Yes, there are.
Cool.
So, first question is, onboarding new consumer chains for interchain security can be seen as a block size increase of sorts. How do we manage this to manage full node requirements?
A block size increase? Not really, because basically what you have minimal communication between the two chains, and that will be the only increase on the side of the Cosmos Hub, just to send validator updates and things like this, which at the moment will be on a per block basis, but this can be easily changed epoch basis, for example. Right, so I don't see any reason to have to increase the block size on the Cosmos Hub, for example, as a result of interchain security.
Okay, I see. And another question is
just one other thing, I think actually to reduce the block space, because now what you have, you can literally shard. You can move whatever is not related to the Cosmos Hub, which should be providing high security, providing routing. The main features of the hub can stay on the hub, but everything else can be moved away in a consumer chain.
I see. Another question is interchain security the only way to strengthen Atom's tokenomics?
Oh, no. Billy talked before. There are a lot of other ideas, and we are very excited about all of them. I think having a stronger community and figuring out how to go about it and how to actually increase the value of the atom as a result of all the features enabled by the Cosmos Hub, right? And that are bringing a lot of value to the entire interchain. So that feeding that back into the atom, that will be great. And there are many other ideas. So I think, yeah, interchain security is only one of them.
Another question is, why are validators not forced to have a reserve to pay for slashing in case of misbehavior?
Sorry, can you go? So why?
Why are validators not forced to have a reserve to pay for slashing in case of misbehavior?
I don't really get. I'm not sure I get the question. So validators do have a deposit. They have to make the deposit, and which will get slash in case they misbehave. So I don't know if I really get the question, what it means.
I'm not the expert for interchain security, so that's why I ask you.
So how I understand this, it will work exactly like in proof of stake, like how it works at the moment. We are trying actually to keep on the consumer chain the same security model as in the rest of the interchain. And this is actually one of the most important things that we are trying to achieve. We don't want to go now and create these new chains with different security models that will have some whatever problems that we didn't encounter. We know that proof of stake works to some degree. It was tested for so many years on so many chains, and we want to replicate exactly the same mechanism, just that we do not want for these new chains to have to bond their own tokens.
Okay, and speaking of battle tested, what is your point of view on the COSM-WASM discussion? Billy had a very similar question on his keynote as well.
So on it being deployed in the hub or not?
Yes.
I think, so it's an interesting topic, right? I think, yes, it could have brought more value to the hub. However, we are so near of actually deploying it as a consumer chain. And I think we have there is this mantra within the Cosmos ecosystem, right? Application-specific blockchains. And I like that, right? So if we start building up different applications on these blockchains, we'll end up with having Ethereum, a bunch of Ethereum chains connected with each other. So I like the idea to have application-specific. I like the idea to minimize the risk, to keep the hub minimalistic, right? And to deploy COSM-WASM on a consumer chain that will enable all the functionalities of COSM-WASM to be on Cosmos Hub, however, without the risk of crashing the hub.
Okay, and earlier in your keynote, you mentioned Quicksilver, the first project that will leverage interchain security. And there's a question, if the hub is a provider chain for Quicksilver, would validators on the hub need to execute blocks of Quicksilver transactions?
Yes, so basically, for every consumer chain that is accepted through governance, that's the reason it's through governance, that's the reason it's not permissionless, at least not at the moment. Because validators actually, once they accept it, they have to start a full node of that chain and run that full node. So in the case of Quicksilver, yes, the validators of the hub will have to run a full node, a full validator node of Quicksilver.
Okay, and I think this is a very interesting question that needs to be asked. Is interchain security from a physical perspective even effective? I mean, how will small validators be able to validate hundreds of other chains parallelly?
That's an interesting question. So we are thinking about whether we can go and move on this to selecting just a subset of validators, right? It's this idea of interchain security V2, V3, where we are trying to have an opt-in, opt-out. We still have to figure out some things that we don't really know how they will work, but we are looking into this. I think at the beginning, there will not be so many consumer chains that will impede validators to actually participate. But yes, that's a very important thing, and that's the reason we are talking with validators and trying to understand what it means for them to run these multiple nodes. The cool thing is that they will get rewards as an outcome, right? And they do not have, now if a validator wants to get more rewards, they need to go and convince that project to join or to buy the token, buy enough of it, or get enough delegations to actually be able to run there. Now you will just get your atoms, you will stake your atoms, you'll get enough atom delegations, you'll become a validator, and then you get access to all these chains.
I see. Last question. Has there been any thoughts on how to encourage data availability into interchain security by allowing interchain security to function using a DA committee?
Yeah, so I was actually talking with Ismail about this. It's a very good question. There are in my personal opinion, yes, I think the two solutions are very complementary, right? So I envision, for example, having a settlement layer from Celestia deployed directly as a consumer chain. I will even go as far as saying that you can even have the DA layer as a consumer chain. But that has different implication from tokenomics and things like this, right? Most likely Celestia will have its own native token that they want, and I think they can attract, being an important project, they can attract easily a set of validators, so that will not be an issue for them. But a settlement layer, yeah, sure, I think that will be something very cool.
Marius Poke.
Thank you.